It's time for Fun with Math, and today we're going to talk a little bit more about understanding logarithms and equations, and really in particular, we're going to solve logarithmic equations today. So let's take a look at the examples we are going to do. So we're going to do 4 problems. Each one sort of builds on the last. So of course we're going to start with A here. A is going to involve using what the log says, using the definition. B, we're going to have to interject some of the properties of logarithms to solve this one. And similar with C and D. But they're going to build, so we want to pay attention to that. But let's start with part A here. So part A, what do we have? We have the log base 5 of 3x minus 8 is equal to 2. So on this one, we're going to use what the log says, and that's where you guys typically get stuck. So you have to unlock sort of the information. And so remember what the log says. If you have log base b of x equal to y, this says, or what it actually means, the definition, is that b to the y is equal to x. So b to the y is equal to x. And I sometimes just use these arrows here. So it's like b to this is that. And so we can do what it says here. So what this says is that if you have a 5, it says 5 to the 2 is equal to 3x minus 8. So what does it say? It says 5 to the 2, so 5 squared, should be equal to 3x minus 8. And once you guys write that down, this is easy to solve because it's basically just a linear equation. So 5 squared is 25, so it says 25 is equal to 3x minus 8. To solve this linear equation now, you're going to add 8 to both sides. So we add 8 to both sides, and we get 33 is equal to 3x. And then we're going to divide out both sides by 3, and this is going to give our answer. So this implies that our x is equal to 33 over 3, which is just the number 11. And we can even check our answer by going back to the original equation and plugging it into our calculator. So if you have your calculator, you may want to take it out and you can check this. There's actually a log base button, I believe under math. Let's go and see if I can't find this, where this might actually be. So under math, if you go to, log base and hit enter, and this won't be on all the calculators, just on the newer versions. You can just type this in. So you can put a 5 there, and then over here you can put a 3 times 11, and then a minus 8, and then in parentheses, oh, I guess there's already parentheses on there. So let's just delete that. So 3 times 11 minus 8. If we hit enter, hopefully we get out 2, and we do. So we checked, we know it's right. Now, if you did not have a log base button on your calculator when you go to math, what you need to do is we need to convert this into ln's. So what you would do is you just write ln of 3 times 11 minus 8, and then divided by ln of 5. And of course, that's using that change of base formula. And if you hit enter, you get out 2, 2. So you can still check it even if you don't have that log base button, which again is behind the math button. And I can just hit up and you find log base there. You hit it and you can enter it like that. But again, not all calculators will have this. The newer ones will. Some of the older ones may not, but you can always use natural logarithms to change this equation into ln's. All right, let's look at another question because that wasn't too bad. So let's look at the next one here. So the next one is what? So the next one is right here. You have log base 3 of x minus 3 plus log base 3 of x plus 23 is equal to 3. Now this one's a little bit different because it's not written as a singular logarithm. So you can't do what the log says. Before you do what the log says, you're going to have to use a property of logarithms, or a log law, or one of those rules that we talked about, to bring these logs together. So remember these sort of log laws here that we have. We know that the log base b of m plus the log base b of n is equal to the log base b of m times n. So we can use this rule. We'll talk about the other two in a little bit, but we can use this rule here to simplify this expression in the sense that we can write it as a single logarithm. So let's do it. So here I can rewrite this as log base 3 of, and I have x minus 3 times x plus 23. And then that's all equal to the number 3. And so now what I can do is I can do what the log says. So remember what the log says. If you have log base b of x equal to y, this says b to the y is equal to x. So it's basically like the same problem, like the problem I had before. So now I can just write this. It's going to be 3 cubed is equal to this thing inside. So this says that 3 cubed is supposed to be equal to x minus 3 times x plus 23. And so what happened here is we didn't get a linear equation. Now we have a quadratic equation. So we're going to solve the quadratic equation. And so 3 cubed, of course, is 27. 3 times 3 times 3. So that's equal to 27. And on this side, we're going to multiply out. So we have x times this and x times that. So it's going to be x squared. And you have plus 23x. But then you're going to take away a 3x. So you just get plus 20x. And then a negative 3 times 23 is a negative 69. And so we're going to solve this quadratic equation. So remember the idea, get all the numbers to one side. So minus 27 on both sides. And we're going to get 0 is equal to x squared plus 20x minus here, 69 minus 27. I just count by tens usually. So 79, 89, and I add 7. So I think that's 96. All right, so here's my quadratic equation. And then the idea is I'd like to factor this. I really don't want to use the quadratic formula if I don't have to. So can I factor it? So is 0 equal to x plus or minus something, x plus or minus something. And I really like this quadratic equation because it sort of shows you the importance of knowing your multiplication tables. Because when you throw out the number 96 at me, basically I go blank because I don't know what times what is 96. It's actually not in my multiplication table. So I have to think a little bit harder. So the idea is you try to think of some factors of 96. So if you think about this, the easiest factor might just be a 2. So this is going to be a 2 times, what is this, 48 maybe? Yeah, I think that's right. That's 40, 40 is 80, 60. Yeah, so 2 times 48. So there's two factors, 2 and 48. But there's no way to add or subtract 2 and 48 and get 20. So I know that's not going to work. So what I can do is try to find 2 more factors by factoring this a little bit further. So like 48 is 2 times 24. All right, so now I have 3 factors. So the idea is you can just put 2 of them together. So I'll put these 2 factors together, 2 times 2, and then there's a 24. So basically you have 4 and 24, and there certainly can make 20 out of a 4 and 24. All right, so 4 times 24 is 96, and then 24 minus 4 is 20. So the answer here is going to be 4 and 24. You need plus 20, so we're going to add 24 and take away 4 from it. And so there's a factorization. You can check it if you want to, multiply it out. You'll see you get this back here. And so then what? So now what do we want to do? So we know this times that is 0, and so we want to set each of these equal to 0. And so let's do that. So what do we have now? We have x minus 4 equal to 0, and x plus 24 equal to 0. And we can add 4 to both sides, so that x is equal to 4. And we can subtract 24 from both sides, get x equal to negative 24. Now I didn't mention this before, but you need to make sure you check your answers, because right now I think both of these are solutions to the problem, but it'll turn out that that's actually not the case. So when you come back in here and you try to plug in 4, if you put 4 here, 4 minus 3 will be 1. If you put 4 here, 4 plus 23 will be 27. And so the numbers are actually okay. But when you try to plug in negative 24 for x, this would be negative 24 minus 3, which is negative 27. When you try to play negative 24 here, it would be actually negative 1. And remember, you can't plug in negatives for logarithms. Just so you can see that, if you take a log of a negative number, say log of negative 5, it's going to say error, non-real answer, which means there's actually an imaginary answer, but not a real answer. And you can go to the error where it has problems, and it'll say after the negative 5. So the one that gives you negatives inside here is not actually a solution. And we'll talk more about that later. So here, we want to put an x through this, and then put a square around this. Right? So this is actually the only solution. You should check your work. So let's check our work on our calculator. So let's plug 4 into here. And so on here I can hit math and go to my log base and put base 3. And when you plug in 4, of course 4 minus 3 is 1, so I have a 1 there. And then I'm going to do a plus, and then when I plug in 4 here, I'm at 27. So again, I can go to math and to log base. And I can put a 3 here, and 4 is 27, so 4 plus 23 is 27 here, so 27. I can hit enter, and I cross my fingers and hope I get out 3, and I do. And since it checks, I know it's right. So remember, you have to do these by hand, but it doesn't mean you can't use your calculator to check your work. All right, so let's look at the next one. So now in the next one, it gets a little bit more complicated. Notice the difference here is now you have a 2 here. And on this side, instead of a number, you have another logarithm. So here we have the log of x plus 9 minus 2 times the log of x plus 3 is equal to the log of 1 over x. So again, what we're going to do is we're going to use these sort of log laws, these sort of rules of log. So we have that product rule we talked about before, but let me write it down again. So log base b of m plus log base b of n. And it wouldn't hurt for you guys to write this down with me, because you'll have to know it for the exam. You won't be given the formulas. So log base b of m times n. So when you add logarithms, you multiply on the inside. Versus when you subtract logarithms, so log base b of m minus log base b of n. So when you subtract logarithms, you don't multiply, you divide. And it's not too hard to remember because it's kind of like likes go with likes. Addition and multiplication go together, and subtraction and division go together. And the third property, right, this was the quotient rule. The third property is sort of this power rule, which says if you have log base b of m to a power, so you have p up here, the power can actually come down in front. So it's p times log base b of m. And so we're going to use these rules and this time to solve this equation. So the idea is you can actually bring these logarithms together, but before you do that, you got to put this up in the exponent. So let's do this one step at a time. So what we have here is log of x plus 9 minus the log of x plus 3 squared. And that's still equal to, on the right-hand side, you have log of 1 over x. So that was by property 3, rule 3, that power rule. And now you're subtracting, so we're going to use this quotient rule here, which says when you subtract logarithms, you divide on the inside. So this is going to be equal to the log of, and you have x plus 9 on top, divided by, and on the bottom you have x plus 3 quantity squared. And then that's going to be equal to log of 1 over x. And so now we're in this situation where we have log of this thing right here is equal to the log of that thing over here. And so we can use a property of logarithms, which we'll talk about in the next lecture, that logarithms are actually one-to-one. Right? They're one-to-one functions, basically. Because they're one-to-one functions, if you have log of this equal to log of that, this has to be equal to that. So you can just drop off the logarithms, basically. So you have x plus 9 over x plus 3 quantity squared is equal to 1 over x. And this works because logarithms are one-to-one. And so now we can solve this rational equation. So notice, in the first problem we got a linear equation, the second one we got a quadratic equation, and now we have a rational equation. And to solve this rational equation, all you're going to do is clear denominators. And so to clear denominators, we'll multiply everything by x, because that'll clear out this, and then also that x plus 3 quantity squared, because that'll clear out that. And so let's do it. So multiply this over here, and what's going to happen is that x plus 3 squareds are going to cancel. And so we get an x plus 9 on top, and then times that x right there. But no more x plus 3 squares because they canceled. And then over here, we're going to multiply all this by this stuff. And so the x's are going to cancel, but you'll still have an x plus 3 quantity squared. And so we go from the rational equation now. When we clear denominators, we have a quadratic equation. We're going to multiply this through by the x and try to get all the x stuff on one side if we can. And so you're going to get x squared plus 9x on the left. We're going to multiply this out on the right. So remember, x plus 3 quantity squared is just x plus 3 times x plus 3. And don't forget, there's going to be a middle term here. So you're going to get the x squared from the x times x. But then you're going to get a 3x here and a 3x there. So you're going to get plus 6x. And then finally, the 3 times your 3 is going to give you the plus 9. So now it's real clear you have a quadratic equation. We'll try to move over the x stuff. So let's just subtract x squared from both sides. This is nice because what's going to happen is the x squared stuff is going to go away. You're going to be left with 9x is equal to 6x plus 9. So now we went from a quadratic equation to a linear equation. And now we're going to subtract 9x from both sides. Oh, I guess we'll move this over, won't we? My bad. So let's move the 6x over. So minus 6x from both sides. Get all the x up on one side. So minus 6x from both sides. And we'll be left with 3x on the left is equal to 9 on the right. Then divide out by the 3. And we get our answer, x equal to 3. It's real simple to make a mistake, so we should check our work. So let's just check our work real fast. So take out your calculator. This one's easy to do because it's just a common logarithm, so you don't have to do any special base stuff or anything. And so you just do log, and we got 3 plus 9. Okay, so 3 plus 9 is 12, so log of 12. And then minus 2 times the log of 3 plus 3, which is 6. And let's hit enter and see what we get here. So that's the answer we get. Now, I don't know if that's this answer over here, so I need to plug in 3 there to see what it is. So I get log of 1 divided by 3. And I see that the answers are exactly the same. So I know that I actually did it right. So if you want, I can put a check right there by the answer because I checked it with my calculator, so I know it's right now. So let's look at this one more time so you can see how this sort of progression works. It's sort of, you have a logarithmic equation. You're going to use the properties of logarithms to sort of bring it all together. So you have the log of something equals the log of something else. Because a log is 1 to 1, this thing and that thing are actually the same, so you just drop off the logarithms. And now you have a rational equation. You clear denominators, you get a quadratic equation. You try to solve the quadratic, it actually turns into a linear equation, and out pops your answer. Let's do one more together. This one involves natural logarithms, and again, we're going to use these rules that I just wrote down. And so here I have ln of x minus 3 minus ln of x plus 4 is equal to ln of x minus 2 minus ln of x plus 9. And what I can do now is when I subtract, I can think about I'm dividing logarithms on the inside, so it's the same as ln of, I'm using that quotient rule, x minus 3 divided by x plus 4. And it should also be equal to the right. Since you're subtracting, you divide on the inside. So divide by x minus 2, or x minus 2 on top, divided by x plus 9 on the bottom. And now I have ln of this equal to ln of that. And because logarithmic functions are 1 to 1, you can just drop off the ln's. So what you have now is this x minus 3 divided by x plus 4 is the same thing, or needs to be the same thing as x minus 2 divided by x plus 9, because logarithms are 1 to 1. That's why this works. And then we have a rational equation now, so now we can clear the denominators. So we'll just do this all in one fell swoop here. We'll just multiply top and bottom, or not top and bottom, but multiply the whole thing by x plus 4 and x plus 9. So everything gets multiplied by this. So you multiply this side by that, and this side by the same thing. And what's going to happen on this side is the x plus 4s are going to cancel. So you're just going to get x minus 3 times an x plus 9. And that's going to be equal to, on the right-hand side, the x plus 9s are going to cancel. And so we'll get x minus 2 times x plus 9. Oops, I made a mistake there. Not x plus 9, but x plus 4. Right? The x plus 9s are going to cancel right here. So x plus 4. And so now we basically have a quadratic equation. We can multiply all this stuff out. So, here you have x squared here. And then you have a 9x minus a 3x. So you get plus 6x. And then a negative 3 times a positive 9. So you get a negative 27. Equal to, you have x times x. So, of course, you have an x squared here. You get 4x here, so x times 4 is 4x, but minus a 2x, let's just be plus 2x. And then negative 2 times positive 4, so you get a negative 8 there. And we want to solve this quadratic equation, so we'll go kind of slow here. Just subtract x squared from both sides, which is pretty nice because when the x squareds go away, you're left with just a linear equation. So 6x minus 27 is equal to 2x minus 8. We'll add 27 to both sides. So 27, oh, and that's supposed to be a minus. Let's change this here. So I copied this down. I wrote this down wrong. So this is 2x, and it's a minus 8. Right? If you put plus, it certainly will be the wrong answer. So then you add 27 to both sides, like we were doing before. And I get what? So nice and slow, showing my work. So I get all the points I can possibly get. So 2x, and that's a plus. So 27 minus 8 is plus 19. I can take 2x away from both sides. And I get what? I get a 4x on the left is equal to 19 on the right. And then finally, I can divide out by the 4, and I get x equals 19 over 4. Right, so there's my answer. I can check it on my calculator. All right, so now when I check this on my calculator, let's see what 19 divided by 4 is, because I'm going to do this a different way, a way we haven't done yet on here. So I got 4.75. So another way to check this answer is you could actually graph the left and graph the right and then intersect. So let's hit y equals, and let's graph the left. This is another way to check our work with our calculator. So I have ln, and I'll type in x minus 3. And then I'll do ln. Then minus, sorry. So we need to do minus then. And then ln of x plus 4. ln of x plus 4. So I'm graphing the left side of my equation here, and I'll hit enter. And I'm going to graph the right-hand side of my equation. So ln of x minus 2. And then minus ln of x plus 9. Now I know my answer is supposed to be 4.75 if I did it right, because I just checked it. Right? It was at 19 over 4. So I'm going to make my window, and I'm going to make my window go a little bit to the left and a little bit to the right. So it was 4.75, and so I guess I'll go like a 4 and then a 5, because I know the answer is supposed to be 4.75. So I just do that 4 to 5, and then I can zoom fit it. So I go to zoom and find zoom fit. You can hit just 0 if you like, but I like to find zoom fit, hit enter. And I should see two graphs, and I should see that they cross near 4.75. So here's the graph of the left-hand side, the graph of ln of x minus 3 minus ln of x plus 4. And there's the graph of the right-hand side. And notice you see them crossing right there. I can even find that crossing point by hitting second trace, and then going down to intersect, and hitting enter, and then just do first curve, second curve, and just hit enter for a guess, and I'll pop right to the answer, 4.75. Right, so I checked my work, so I know it's right, and so I don't have to worry about getting this problem wrong. All right, so that's basically how you solve logarithmic equations.